All right, so today we're diving deep into something pretty cool. You ready for this? Cryoluminescence.
Cryoluminescence.
Ever heard of it?
It's kind of a mouthful, isn't it?
It is. But it's basically light being emitted during freezing.
Yeah. You know, light from freezing, it sounds a bit strange, right? Like, how can something get colder and give off light at the same time?
I know, right? It's like the opposite of what we normally think of, right? We think of heat and light going together.
Exactly, like a fire.
Exactly, a fire.
But cryoluminescence is kind of flipping that idea on its head. It's a super cool phenomenon. I mean, it shows us that even in that transition from liquid to solid, energy can be released, and sometimes that energy takes the form of light.
Yeah, and you know what? It's more common than you might think.
Really?
Yeah, think about those window green lifesavers.
Oh, yeah. When you bite into them in the dark and you get that little flash of light.
Exactly, that's cryoluminescent in action.
That's amazing. I never knew that's what it was called.
So we're talking about some serious science behind those sugary sparks.
Absolutely. There's some really interesting stuff happening at the molecular level to make those little light shows possible.
Yeah, so before we get too far ahead of ourselves, let's maybe kind of take a step back
Yeah.
and really break it down for our listeners.
Yeah.
What is actually going on when we talk about this transition from liquid to solid that causes light to be emitted?
Okay, so imagine a bunch of molecules in a liquid, right? All jumbled up, moving around quickly, bumping into each other. It's kind of chaotic.
Like a mosh pit.
Exactly, like a molecular mosh pit. But as the liquid starts to freeze, those molecules start to slow down, and they start to arrange themselves in a much more orderly way, like a crystal structure. It's like they're snapping into formation.
They're finding their assigned seats.
Exactly, finding their assigned seats. And this process of becoming more ordered, of forming that crystal structure, releases energy, and sometimes a portion of that energy is released as light.
So it's all about this transition from disorder to order.
Precisely.
Kind of like that chaotic dance floor suddenly turning into this perfectly synchronized waltz.
I love that analogy.
But this isn't just like, water freezing into ice, right? I've read that certain chemicals and solutions exhibit this phenomenon too.
That's right. It's not limited to just water. And that's because it all boils down to what's called a phase transition. That's where a substance is changing its state from a liquid to a solid.
So just to clarify, it's not just any phase transition though, right? It has to be one where there's this specific type of energy release that produces light.
Exactly. It's not just about things getting colder and solidifying. It's about the way they do it, about the energy dynamics involved. And that's what makes cryoluminescence so fascinating.
It sounds like we're tiptoeing into the world of low-temperature physics here.
Oh, absolutely. We're talking about temperatures where things get seriously weird, where the rules of how matter behaves can seem almost, I don't know, magical.
It sounds like it.
And cryoluminescence is just one tiny example of all the strange and beautiful things happening in this really cold realm.
I'm ready to bundle up and explore, but before we dive too deep into that low-temperature rabbit hole, let's bring it back to Earth. I was reading about, a possible connection between cryoluminescence and like those really mysterious glowing clouds you see sometimes.
You're talking about noctilucent clouds, right?
Yes, noctilucent clouds, yeah, those are the ones.
Yeah, they're amazing. And there is actually some speculation that the luminescence you sometimes see in the ice crystals that make up those clouds, it could be due to cryoluminescence.
Really?
Yeah, imagine that, like tiny little ice crystals high up in the atmosphere emitting light as they form.
Now that's a sight I'd love to see.
It's incredible, isn't it?
It makes you wonder what other secrets are, sort of hidden in this seemingly really simple process of freezing.
And that's what we're here to uncover. So we were talking about those mysterious glowing clouds. It just really makes you wonder what other secrets are hidden in this like seemingly simple process of freezing.
Yeah, and earlier you mentioned something about potential applications for cryoluminescence, and that's something I definitely want to dig into a little bit deeper.
Oh, absolutely. This is where things get really exciting. Imagine a world, right, where instead of relying on heat to create light, we could harness the power of freezing.
Okay, now that's officially blowing my mind. Are we talking about like replacing light bulbs with ice?
Well, not exactly ice, but you're getting the idea. Remember how we were discussing earlier how energy is released during crystallization?
Yeah.
Well, scientists are actually investigating ways to capture that energy and amplify it, and potentially even convert it into usable light.
So instead of like flipping a switch and sending electricity to a filament that heats up and glows, we could have some sort of device that triggers a freezing process that releases light. It's almost like nature's light bulb.
Exactly, and think about the implications of that. We could potentially create lighting that requires significantly less energy, leading to, huge savings in power consumption and a smaller environmental footprint.
That would be a total game changer, especially as we're trying to move towards more sustainable energy solutions. But, you mentioned other applications as well. Something about sensors, I think.
Right. Cryoluminescence could also change the way we detect and monitor changes in temperature. Imagine a sensor, right, embedded in a bridge or in an airplane wing that uses cryoluminescence. As soon as the temperature drops to the point where ice starts to form, the sensor could emit a light signal, alerting us to potential dangers before they become catastrophic.
That's incredible. We're talking about preventing major accidents, saving lives. It's amazing how something as seemingly simple as light from freezing could have such a huge impact on our world.
And we're just scratching the surface. Scientists are exploring applications in fields ranging from medical imaging to material science. For example, you could use cryoluminescence to create incredibly sensitive detectors that can pick up tiny, tiny temperature fluctuations in the human body that could lead to earlier and more accurate diagnoses.
So we're talking about some seriously advanced technology here. It sounds like something straight out of a sci-fi movie. It's just mind-blowing to think that all of this stems from a phenomenon that most people probably don't even know exists. It really makes you appreciate the power of scientific curiosity and the unexpected places that it can lead us.
Absolutely. Cryoluminescence is a perfect example of how exploring the seemingly mundane can unlock these extraordinary possibilities. It's a real testament to the fact that there's always more to learn, even from the things that we think we understand.
I'm definitely feeling inspired to go do some more research on this. But before we wrap up, I have one question that's been kind of nagging at me. We've talked about cryoluminescence happening in candies and chemicals and maybe even in clouds, but what about life itself? Could there be biological systems that actually utilize this phenomenon in some way?
Now, that's a truly fascinating question. We know that bioluminescence exists, right? Like fireflies and deep sea creatures that emit light. Could cryoluminescence play a role in the incredible diversity of life as well?
It's a really cool thought, the idea of a creature that actually glows when it freezes. I'm picturing like some sort of Arctic animal that uses cryoluminescence to communicate or attract mates or even, ward off predators.
It might sound like science fiction, I know, but when you consider the sheer diversity of life on Earth, it's not entirely implausible. I mean, think about it, there's still so many mysteries hidden in the natural world just waiting to be discovered. And maybe, just maybe, cryoluminescence might hold the key to unlocking some of those secrets.
I don't know about you, but I'm like totally geeking out over here.
Yeah, it's wild, right?
Like, we went from sparking candies to the possibility of, cryoluminescent creatures, all in one deep dive.
It's amazing how something as simple as freezing are open up all these new worlds.
Yeah, and that's what makes science so cool, right? It's this never-ending journey. You're always exploring and finding something new.
Exactly. It's like every time you think you've figured something out, something else comes along and just totally changes your perspective.
I know, it's humbling, but in a good way, right?
Oh,
I
absolutely.
definitely feel like, I've only just scratched the surface of cryoluminescence, but I'm hooked.
Me too. I mean, who knew there was so much to learn about freezing?
All right. I'm going to be looking at those window green lifesavers in a whole new light from now on.
I bet you will.
Maybe this deep dive will inspire someone listening to, make the next big breakthrough in cryoluminescence research.
Yeah, wouldn't that be awesome? Maybe one of our listeners will be the one to, discover that glowing creature we were talking about or invent some incredible new lighting technology.
Man, that would be amazing. Well, I think that about wraps it up for us today. We've covered a lot of ground, from the basics of how cryoluminescence works to its potential applications and even, the possibility of it being part of the biological world.
It's been quite a journey. I think we've given our listeners a lot to think about.
Absolutely. And for anyone listening, we hope this deep dive has, sparked your curiosity. I hope it's inspired you to keep exploring the wonders of science, because there's a whole universe of amazing discoveries out there just waiting to be uncovered.
So keep asking questions, keep learning, and keep that scientific spark alive.
And on that note, we'll say goodbye for today. Thanks for joining us on this awesome journey into the world of cryoluminescence.